you are going to consider a mechanics problem in which this particle is going to slide down on this. It will be rolling down and then it will come here. Now once it reaches this particular point, and afterwards the contact between the larger sphere and the particle itself, that contact will be lost, and then the particle will come down and fall here. As long as it is in contact with the surface of the sphere, you want to determine the equation of motion. So once it leaves the contact, then it is only a matter of free fall. But as long as it is in contact with the larger sphere, then it is going to travel on the surface of the sphere. The particle is traveling on the surface of a sphere of radius a. Of course, that immediately you can write down that the equation of the sphere is x square plus y square plus z square is r square. So that would be the equation of the sphere. On this sphere only the small particle is going to travel. So the equation of the sphere is entering into picture means the coordinate system, it would be better to choose spherical polar system instead of Cartesian. So now you understand what do you mean by saying a particular physical system is having spherical symmetry. So this is the example. This particular circle is in the xy plane, or we say that it is the horizontal plane. Generally horizontal plane is known as the xy plane in Cartesian system, which means that you can assume that there is an x-axis here and there is an y-axis here. So x and y are on these two lines. Suppose if you are going to put a torch light here, so you are going to put the light vertically down in this direction. This particular rod will create a shadow. It is known as the projection, or we say that it is the length of the shadow. So in terms of mathematical language, this is the word that we will be using. It is the projection of the rod on the xy plane. So the orange color line that is shown in this diagram is the length corresponding to the projection. So this is the length of the rod. I have taken r, and if the angle is theta, if this is the angle is theta. So how much will be the projection of the rod is that this will be r and this is theta, and therefore the projection should be equal to r sin theta. So our conclusion is this, that the projection that we are going to get here is given by r into sin theta. The second thing, let me draw another simple diagram. We'll say that the length of this hypotenuse is equal to r sin theta. And then we will consider a different angle now. So and now you ask the question, can we put a theta here? You can't put, because already theta is used here. The theta is already used in a previous diagram, and put a different, any other different symbol you put. Let us use that angle is phi. This is r sin theta. You have the r sin theta, because this is the horizontal component, then that must be multiplied by cos phi. And multiplied by, since it is opposite side, we can write as sin phi. Till this discussion, what are the variables that we have? We have this particular r, comma, we had a theta, here it is there. So there was a theta in our problem, and then now here it is a phi is there. Three variables are involved in this particular calculation, and as you see that the calculation is very simple. It is only a matter of decomposing the hypotenuse into the perpendicular and parallel components. If you know this much, then the spherical polar coordinate system becomes very simple. So let me draw the sphere now. Okay, so here I have drawn a sphere. So the blue color shade that I am showing here is actually the xy plane. Yeah, by the way, xy means I have to show here. This will be the x-axis that you have, and then let us say that this is the y-axis, and therefore this will be the xy horizontal plane. The blue color one shows the xy horizontal plane, which is the section of means if you cut the sphere, then whatever is visible, and that is known as a section, and that is the horizontal plane that we have, and let the z-axis be the vertical one. So we have drawn a sphere, and that is clear, and certainly origin should be there. So there is an origin here. Now once this is clear, now we need to identify where is the radius of the sphere r, and where is the theta, which is the angle that we are planning to have in the case of spherical system, and then where is the phi. So we need to identify where are the three variables in a sphere. Now once that is clear, then if you combine these three numbers and keep it as a tuple, so we'll say that this is a tuple. These three variables r comma theta comma phi has to come in this order only. That is called ordered. You can't interchange them. You can't say that I will write theta first, then r, then phi. Like this I will write. If you say that okay, you can write, but this is not a spherical system. And the set of these three numbers will represent a point P on the sphere. You can follow this white color cursor, and let us say that we will choose a particular point here, and let me put a dot here. So that is a point on the sphere. We can say that this is P if you want. So this is the point P, and then this P can be located, or this P can be characterized by having three numbers r comma theta comma phi, and we are going to ask the question, show me where is small r, where is theta, and where is phi.